Today we're going to be learning to solve systems of equations using technology. The technology that we'll use today is the Desmos Matrix website. However, you can also do these in a graphing calculator such as the TI-84 that we use in the classroom. Let's first talk about some vocabulary terms, so be sure you're writing these definitions down. A matrix is a rectangular arrangement of numbers, and within the matrix we have elements, and those elements are the numbers that we put into the matrix. Our matrix has a size. We have rows and we have columns. Remember that the number of rows are the number of equations that we're going to use actually. And so our dimensions are m times n, where m is the number of rows and n is the number of columns. With our technology, we're going to input an augmented matrix. What augmented means is that it's not just the left-hand side of the equation, but we have augmented the matrix or made it larger by also putting in what all of that is equal to. So by putting in the equals d at the end, that we have augmented or made the matrix larger. An augmented matrix needs to be written in standard form, just like you see here. AX plus BY plus CZ is equal to D in that order. All of the equations must be in the same order in order for this to work. And then our matrix consists of only the coefficients and the constants. That's why it's super important to make sure that your variables in each equation are in the right order. I said that we're going to use Desmos to solve these, and I just want to make a note that this is desmos.com/matrix. You don't navigate just to desmos.com to the graphing calculator. You need to put /matrix in order to get where we're going. And what we're going to be using is a technique which will give us the reduced row echelon form, or RREF for short. All of the steps are listed here. I'm not going to go over those because I'll go over them within the examples that we do later. I do want to go ahead and show you what our solutions are going to look like. Our scenario where we actually have a solution, how you're going to know that is you're going to have this diagonal row of ones. And if you have this diagonal row of ones, this is our solution. -1 is the x, 3 is the y, and -4 is the z. Because when we rewrite the matrix, putting back in our x, y, and z values, you can see that we have 1x is equal to -1, we have 1y is equal to 3, and 1z is equal to -4. So our ordered triple would be -1, 3, -4. If we have no solution, so this first one is when we actually have a solution. If we have no solution, we don't have that diagonal row of ones because we have a 0 in this last column right here. So if we have all zeros and a 1, it could be written like this. 0 times every variable is equal to 1. Well, we know that anything times 0 is 0. And so that reduces to 0 equals 1, which is a false statement, making it no solution. Finally, the third option that we could have is that we might have infinitely many solutions. How will we know that? Again, we're not going to have that diagonal row of ones, but instead of a series of zeros followed by a 1, we're just going to have a series of zeros. That is going to reduce down to 0 equals 0, which is a true statement, and so that means that we have infinitely many solutions.